For millennia, humans have wondered about the extent of the cosmos. Ancient civilizations looked to the night sky and wove epic stories, imagining celestial kingdoms and realms of gods. But today, modern astronomy has taken us further than those ancient storytellers could ever have dreamed. Now we're left with a new and astounding question. What lies beyond the region we can actually see, beyond the edge of our observable universe? The observable universe is often described as everything we can detect with our telescopes and instruments, extending roughly 46 billion light-years in every direction from Earth. That's a mind-boggling span of galaxies, stars, and other celestial wonders. However, due to the universe's expansion and the limit of how fast light can travel, there's a boundary to how far we can see. This boundary is not a physical wall, but rather a horizon created by the speed of light and the age of the universe. If something is too far away, the light it emits can't reach us in time to reveal its location. This is why the very concept of an edge is both awe-inspiring and a bit misleading. Scientists often compare the cosmic horizon to standing on an expansive beach. You see the water stretch out until it meets the horizon, but you know the ocean doesn't end where your vision fails. The cosmos may be infinitely large for all we know, yet our instruments can only see so far. Even so, that leads to an inevitable question. If the universe is bigger than what we observe, could there be entire realms of galaxies and cosmic structures beyond our line of sight? And if so, how do we even begin to explore or prove their existence? Modern research suggests our cosmic horizon does not mark the end of reality. Many theorists propose that, beyond this limit, the distribution of galaxies, dark matter, and dark energy continues in a manner similar to what we see nearby. If you took off on an imaginary spaceship and somehow traveled beyond our observable boundary, you'd likely encounter more stars and galaxies that are very much like those we see around us. It's a humbling idea that we might inhabit just one neighborhood of a grander, possibly infinite cosmic metropolis. Interestingly, some ancient texts also hinted at an unending cosmos. In certain passages of holy books, the vastness of the skies is often described in poetic terms, as if the heavens stretch on without end. Ancient seers might not have had the language of modern physics, but they recognized something profound about the boundless nature of creation. In other beliefs, like certain Eastern philosophies, the universe is described as cyclical or endlessly layered, which resonates loosely with our modern concepts of infinite space and cyclical cosmic events. In scientific terms, the shape of the universe plays a vital role in figuring out what might exist beyond our horizon. Observations of the cosmic microwave background, sometimes called the afterglow of the Big Bang, suggest that our universe is remarkably flat. This flatness implies that parallel lines drawn across cosmic distances would never curve back on themselves, as they would in a spherical or closed universe. If the cosmos is flat, or very close to it, that strongly hints it might continue indefinitely, transcending any horizon we can observe. In other words, there could be infinite regions, each resembling our slice of the cosmos, stretching out forever. However, there's another possibility that intrigues scientists and philosophers alike. Cosmic inflation, an incredibly rapid expansion that occurred fractions of a second after the Big Bang, might have produced a scenario in which the universe is not only vast, but also fragmented into bubble universes. This idea, known as the multiverse theory, suggests each bubble could be a separate domain with its own physical laws or values of fundamental constants. Our observable universe might just be one bubble in a cosmic foam of countless others. While these ideas venture deep into the realm of theoretical physics, they are taken seriously by many researchers because they help explain phenomena such as why our universe's conditions allow galaxies, stars, and life to form in the first place. If that sounds like pure speculation, consider how inflation theory predicted the existence of fluctuations in the cosmic microwave background long before we measured them. These ripples were eventually detected by satellites like COBE and WMAP, giving us insights into the early moments of our universe. The success of those predictions has led many to trust inflation theory as a compelling framework, and within it, the possibility of an unending labyrinth of universes emerges almost naturally. Mystery deepens even further when we try to reconcile these cosmic ideas with quantum mechanics. The quantum world suggests particles can pop in and out of existence or exist in more than one state until they're observed. At cosmic scales, this might mean entire regions can fluctuate into being, each potentially spawning its own version of reality. This strange concept echoes ancient beliefs where worlds emerge out of a primordial void or cosmic ocean. Ideas found in old texts and mythologies from around the globe. It might sound mystical, yet cutting-edge physics sometimes reads like a mythology all its own. Still, direct evidence for what lies beyond our observable universe remains elusive. Our telescopes can only see as far as light has had time to travel. If there are other regions, and if they're receding from us faster than the speed of light due to cosmic expansion, we'll never see them directly. Some scientists hope advanced gravitational wave detectors might one day pick up subtle signatures from beyond our visible horizon, like cosmic collisions or disruptions that traveled across the cosmos. Others wonder if strange imprints on the cosmic microwave background might offer indirect hints of other bubbles colliding with our own in the distant past. Yet the question of what lies beyond isn't strictly about more stars, galaxies, or even parallel realities. It also touches on our deeper yearning to understand existence itself. The edge of the observable universe can serve as a metaphor for the edge of human knowledge. Beyond it, we place our greatest hopes, theories, and dreams, a realm that triggers profound curiosity and at times existential wonder. Some might say that since we can't directly confirm these possibilities, there's little point in speculating. But history shows the power of daring questions. People once believed Earth was the whole world. Discovering the rest of our planet demanded voyages into the unknown. Then, we realized our world is just one planet in a solar system, which is itself one of billions of star systems in our galaxy, and our galaxy is just one among potentially 2 trillion galaxies in the observable cosmos. Every step we've taken has extended our horizons, literally and metaphorically. Who's to say that beyond our current horizon doesn't lie a revelation so transformative it will once again reshape how we see ourselves? Modern astronomy presses on, using telescopes like Hubble and the James Webb Space Telescope to peer deeper into time and space. We're capturing images of galaxies as they appeared just a few 100 million years after the Big Bang, pushing ever closer to the ultimate boundary. Meanwhile, teams around the world work on next-generation observatories, hoping to discover signals of what came before the cosmic microwave background, or how dark energy might guide the future of universal expansion. The more we learn, the more we suspect that our cosmic horizon is but a single frame in a much grander cinematic reel. Even within our observable patch, we've found phenomena that challenge our sense of scale. Superclusters of galaxies stretch hundreds of millions of light years. Dark energy accelerates the universe's expansion, ensuring that distant galaxies will slip beyond our view one day, never to be seen again. These facts alone are extraordinary to contemplate. Now imagine an entire realm of space beyond that, with even more majestic structures, or different physical constants, or phenomena we can't begin to imagine. It could be calm and familiar, or chaotic and utterly alien. Whether or not we ever uncover definitive proof, the scientific consensus points to one crucial insight. The universe is likely far larger than the sector we can observe. For many, that's a staggering reality filled with spiritual and philosophical implications, reminiscent of lines in ancient scriptures that speak of heaven spanning immeasurable heights, or lost tribes telling stories of endless seas and hidden continents. Our ancestors might have been referencing something deeply intuitive about humanity's place in the grand tapestry of creation. In the end, our quest to know what lies beyond the edge of the observable universe fuels both our rational curiosity and our sense of wonder. It reminds us that each generation stands at the frontier of knowledge, gazing into the unknown and daring to ask, what's out there? These cosmic questions help define us as a species forever seeking answers, and they hint that the greatest discoveries may yet lie just beyond the horizon of what we can currently see. If the cosmos stretches on infinitely, then so does our opportunity to explore, learn, and find meaning in the majestic realm we inhabit, both the part we can see and the parts we can only dream about. Subscribe for more.